when I prepare these slides, each time if I reread it, I probably can find way to improve it too. So if you do not reread your own work, you're not going to improve. Okay, so if you want to become a better writer, okay, over time, then check your word, and you quickly figure out what is study word. It doesn't, I mean, study life, like it's very unclear. Okay. So sometimes we want to not just telling their operation, but what do they make up of? For example, when you say learning material, you probably can say learning material consists of, for example, do I have it here? Okay, maybe I didn't say it here. Maybe I say it in the detail notes. If you open the PowerPoint, there is a bottom portion that shows some detail notes that I want to add in addition to, because for a slide, this is already too many words. Okay, in fact, in normal cases, we don't put so many words in here, but in this case, allow me to make that mistake. And but so for learning materials, we want to say it also consists of teaching material in PDF, or maybe exercise and answer. So you can, in addition to just saying who can do what about it, okay, the operation on it, you can also say what it consists of. Okay, and in the case of parents, you can also say that when a student enroll for the first tutorial, the information for the name and contact information for at least one parent must be collected. Okay, so this way you can express some business rule, okay, that may not really be enforced by the system, okay, because it maybe it's up to the person who handle the new student joining the class. But you can say, okay, name and contact information of parents should be collected when the child join for the first time. So these are the additional information you can put in the business glossary. Okay, so try not to limit yourself to those operations. Okay, and cross-platform is not the best thing to include here, although it doesn't hurt. Okay, I will not count it as a mistake if you define cross-platform. But if you read through it, you would see it is really a requirements. Okay, so if you put a requirements under the heading of business glossary, then it really doesn't help. Okay, and also cross-platform is not a term in the business of private tutoring. So we want the business glossary usually should be focused on the business terms, okay, not the technical term. So for both reasons, it will make cross-platform not the best thing, not the most valuable thing to include in a business glossary. Okay, week 5 is not our priority in this course, like the drawing of the screens, but the main thing that I included is to let you see that when you design the screens, quite possibly you will find out that you need to revise your acceptance criteria. Okay, I just want you to experience that. So the product of your screen design actually is not terribly important for this course, because we really didn't get into teaching you how to design screens. Okay, and there are different reasons that revision to the acceptance criteria is necessary. For example, something you may find out is very difficult to display or implement. Okay, or maybe even if you can implement it, it won't be easy to use. And or maybe that when you talk to the users seems to now have more things that they want to see, okay, which may not have expressed in the acceptance criteria. So you may need to add it. So week 6. Week 6, what you did was you divide user stories, I think, into programmer task, and then you go through use the Delphi method to estimate them. Remember the Delphi method, the essence of Delphi method is each person independently estimate the effort, okay? Be it you're using person day or story point, either one, okay? And also you can use the full range of integer number like 1, 2, 3, 4, 5 on the unit, or you can use the planning poker, okay, which skip those numbers that are not Fibonacci number. And the nature of Fibonacci number is the bigger you get, the number get, in fact, the bigger the gap between the consecutive Fibonacci number. The main reason for that is to allow you to arrive at a consensus, okay, quicker, okay. So when the number get somewhat big, let's say the unit of 13 or 14, it will be different, right? If one person, if they're allowed to use 13 and 14, but let's say if by using Fibonacci number in the planning poker, you can, I think after 13, the next one would be like very big, like 5 or 6 more, okay? Then people would converge to 13. So even though the best estimate may actually be 14, but at the estimation level, we really cannot insist that we are so pinpoint at 13, 14, 15, okay? So estimate is only very rough anyway. So there is no need to be 100% accurate with estimation for our Scrum management, okay? For other type of things, maybe you need more accuracy, but in software development, we really experience told us that we really cannot always expect to be like right on the original estimate. Okay, so these are the mistakes people make. Sometimes a student gave me a list of programmer tasks, but then they didn't say what user story it is for. So for me, I really cannot tell whether those programmer tasks make sense for the user story. Is a meaningful breakdown? I don't know. Okay, and also sometimes students did not say. I asked the 4 team members to try the combination of person days story point and also planning poker or without planning poker, but student did not say which one he or she is using. And sometimes the programmer tasks do not seem to relate to the user story, or it's all right that they are related to the user story, but then there's no correspondence with the acceptance criteria. This is not always mandatory, but it's helpful, okay? It's helpful that when you think about programmer task, you you try to relate to the acceptance criteria. That would be a good practice. Okay. Okay. Sometimes teammates submit identical estimates on identical programming task. I really don't know how to give them mark because that means they didn't do their work. Okay, so they just copy from one person in the team and then submit it. Okay. Also, sometimes some of them give identical round one estimate, and then they still do a round two. Why? Why do you need round two? Okay, so you don't understand that the objective is for the estimates to converge. But if you already converge to the same estimate, there's no need to estimate again, right? Only if there are differences, then there needs to be discussion, there needs to be re-estimation. Okay. Also, I asked you to reflect on which one you like better, but then some people don't reflect on it. Okay. So my guess is that not the full team had attended the tutorial. That's why I came the policy of taking attendance after that. Okay, so and of course, it's clear that they don't seem to understand the nuts and bolts in Delphi estimation. Okay, some mistakes. Okay, some students did not read the question carefully. I asked that each student would do it for one user story. Okay, but then some students submit the work of many user stories. So that means for not reading the question carefully, they did a lot more work. Although that may not be the worst. The worst is it just take you more time. But another perspective is if you do one, okay, that means you can focus and do a very good job on working on one user story. But if you do many user stories, then that means you get sort of distracted. Okay, you cannot focus on one very carefully. Okay. One student very kind to guess why there may be round one and round two are the same. Okay. Oh, okay, I see. So maybe just maybe CM give the instructions for you to just copy the things over to round two. Okay, so that's fair enough, I guess. But now you know it's not really necessary. But perhaps CM give you that instruction. That is, just copy all the numbers from round one to round two for consistency. Okay, for that you don't have an empty column. Okay, that's all right. Okay, but that is not really necessary. Okay, that's what my point is. Okay, so not necessary. So now I get it clear now that you didn't do it wrong. Okay, you get the permission from your tutor. Okay, but now you know. Sometimes actually in a very tricky case, you may need to go for round three. Okay, although if you really go to round three, then maybe the most experienced person will have to draw a line, like sort of to decide what the estimate should be, because the people just don't agree. Like sometimes it happens in practice, okay, because of our different experience. So maybe you which estimate to use at the end maybe you would use the one that they say. Like for example, I give you an example is if one person say is 5 days, another person said is 8 days, and they cannot agree after some debate. Well, maybe for you as a leader, okay, like a scrum master, or then how about give the job to the person who give a short estimate, okay? So that way he can prove that he's right. And it might also be dependent on who is doing that, okay? If the strong person is doing that, he can do it in 5 units, okay? But a weaker person may feel that I'm doing it, I need 8, okay? So you can use that as I guess a way out of the difference. Okay, some students use not allowed number even when they are doing the planning poker. So clearly they don't understand. This is the last mistaken estimates. Well, some students use 1 as an estimate for a particular task, and they have overlooked the definition of the story point. Okay, a story point is we defined the smallest possible task to 2 story points. So that means in reality there will not be any task that takes 1 story point, because otherwise it will violate that our definition, because we want to make use the smallest task as a reference that it contains 2 story points. So the smallest number of story points you can have for any task is just 2. Okay, if you have 1, then that should be redefined as 2. Okay, and also some students gave me estimates 5, 8, 5, 5, and then they use the final value of 6.5. So I figured that out. Well, maybe they don't understand the meaning of median. The median is sort of, if you have a bunch of numbers, and if you sort them in order, it is the middle number. Okay, if you have even number of estimates or numbers, then it's the 2 in the middle, and you take the average or the midpoint of those 2. So median of 4 numbers is not the same as average of 4 numbers, because median for 4 numbers is just taking the middle 2 and take the midpoint of it. Okay, so this is why I asked you to present them in ascending order to make the midpoint more easily discovered. Okay, and so some students clearly don't understand it. You're basically wasting your time of doing the work. Okay, if you don't try to understand the method or the desirable outcome. So now I'm showing you an okay use case description, but there's room for improvement. Okay, okay meaning that not meaning that it is good. Okay, but it is probably it won't fail a test. Okay, put it this way. But if it passes, it will probably be the lowest, like 40 or 50 kind of score. Okay, so if you want, you can take a look, and when we come back in 5 minutes, okay, we will discuss what's bad about it and see if you get the same list of mistakes as I do, and also we will try to improve it, and also you can try to do that. So maybe 5 or 6 minutes. Of course, you're entitled to a short break too. So I may call you back maybe in maybe 7 minutes, let's say. Okay. So see you in 7 minutes. I'll get some water and walk around a little bit. Timer for 6 minutes.
Sure, 6 minutes. And that's starting now.
Okay, so let us resume. But before we resume, let me ask you, for every hour of contact time, how many hours do you think you should spend you should spend studying or doing homework? Okay, let's say. Uh, I guess based on the fact that a full-time study workload is 4 courses and a full-time job is 40-hour week. Okay, that means each course you should spend 10 hours. So for 4 hours class contact time, you should spend about 6 hours in addition to study or to do homework. Okay, so this is what a full-time job is supposed to mean, right? So that is each hour contact time correspond to 1.5 hour study time. Okay, which is pretty close. When I was a undergraduate student, my first year professor told me each hour of contact time you are supposed to study 3 hours. Okay, so actually we study 5 courses at any time, and we have 3 hours lecture a week. So 3 hours lecture plus let's say 6 to 9 hours study time. That is maximum 12 hours, like 9 to 12 hours. So nine, let's say the low end, 9 times 5 is 45 hours. So you guys actually have like a better time than I mean less work when comparing to I was a student. So uh, but right now I try to this is my strategy, okay, or my plan. That is, after the 2 hour Zoom lecture, I hope you would spend 1 hour. That would be enough for you to fully understand the slides. And then for the 2 hour lab work, uh, of course, for the studying, the 1 hour studying after lecture should happen before the tutorial, okay? Otherwise, you would have to spend more time, okay? So 2 hour lecture, 1 hour studying, and then 2 hour tutorial, and potentially you may not finish your work and you have to spend 1 hour, okay? Addition after class, after the tutorial. So that is still just 6 hours for my course. So I guess you guys got a very good deal. Okay, so comparing to the time I was a student, you only studying half the time. Okay, so I guess there's really no reason to do badly. But let's say if I didn't achieve my plan, okay, that is, you find out you spend more than an hour to study, okay, to review your slides. And also after tutorial, you spend more than an hour to do it, okay. 1 or 2 hours, give and take. So if it's much more than that, please feel free to message me in class or email me. Then I would probably adjust it. Okay, I would probably adjust it. So let's go back to our use case description by student. Okay, I may go back and forth with the example. In the use case name, the word record is used. Okay, read homework record. Why the word record is needed? Okay, how about just read homework? Okay, so for it's just a suggestion. Okay, so if you have a very strong reason not to keep the record, okay, then maybe you can consider it. But I guess in this case, it's probably not a very good one. He or she have, okay, is a very simple grammatical mistake. And event one was an incomplete sentence. Student log into the what? Okay, so maybe the student was looking for the best word to use, but then he forgot to finish it. Okay, and also the use case was for the student to retrieve whatever he or she has submitted. But if he submitted it, why would he or she needs to retrieve it back? He or she should have a record. So I'm wondering, do you mean he wants to find out his score or find out her the feedback received from the tutor? Okay, so by changing the use case a little bit, you can add more value to it. Otherwise, this is only like a backup. Okay, you just want to see what you have submitted. Okay, this is not a lot of values. You can add more value by making it reading feedback. And events 3 and 4 are internal to the system. So let's see what it is. The app sends a request to server to ask for the record of handed in homework. The app received the record. Okay, these kind of actions we probably I call it internal. Okay, versus there are some external things done by the system. For example, the system displaying something to you, that is an external thing because it's visible to you as the user. But this sort of things is totally internal and internal to how the system does its work. And the whole point of having use case description is to describe the user requirements. And the user really doesn't care how it was implemented internally. Okay, so I think we introduced the term last time called over specification. When you specify requirements, you just want to specify the requirements. You don't want to specify how the solution should be built. So this is sort of getting into the solution. So try not to do that. Okay, event 5 says list of records is displayed. It is unclear what's really shown. Okay, so yeah, displaying list of record and what is a record? Okay, it is unlikely that the student remember to do it in the business glossary. But even if he does, then that would be sort of another place in a long document. So it's not a definition, a piece of information nearby. So there's benefit for you to say, if you want to say display the list of record, then what a record consists. Okay, put it in a bracket and list out the, let's say, 3 items in a record that you want to show. That would be better. And so, yes, finally, there is one thing about that is 90% of users can load the data within 1 second. But this operation is likely done over the network. And so, but you are saying requirements that depends on the network time, which you have no control whatsoever. So, of course, you would say, I do have these requirements, right? So what can I do? Well, you may have to add a little bit of condition in it, okay? So you may still have a specific time requirement, but you may want to add some assumption about the network response time, okay? So is a tricky thing to do. Okay, it's not an easy thing to do. Or another thing is you just take out the network time. Okay, you just specify the system response time. Okay, so assuming if the request was made on the same premise, that is, the request does not need to go to the public network. How fast is it? So you can do this like work around when you want to specify the performance of the system. Okay, because network really is not the part that you can have control. So these are the things you want to be careful. And so now this is my attempt to revise it. So I add a little bit of functionality, okay, not just retrieving the homework, but I want to read the tutor's feedback. So read tutor feedback. And then here I select it from the feedback page, and the app displays list of submitted homework and listing from recent to old. Okay, no need for the search function. Okay, in fact, here it doesn't say things would be in order. So that actually, but this is important that things are in the recent ones are listed first, because otherwise, if they're in random order, then that list won't be very useful. So, so I'm adding this. Okay. Okay. A score will be shown if the homework has been marked, and if tutor has given feedback, then the feedback unread column will have a mark saying to indicate that some feedback is there for the student to read. Okay, and the student can select it, and then the app displays the homework if available, also the tutor's feedback. So this provides us the original functionality of displaying the homework as well as the feedback, and is explicit right now. Okay, better than just displaying the record. But what is a record, right? And also this return tell us where it returns to. Okay. Okay, sorry. I was doing this. I have not finished reviewing this part, but for this part, I haven't finished it. But this part probably should say that the feedback unread status should be updated in the database. But of course, I don't need to provide the database. I'll try to revise it when I go back, but I would say the status of feedback unread of the record, just view, will be updated to read. Okay, and the quality requirements, I may say 90% of the request will have a 1 second response time. Or I may also say that with let's say a certain number of concurrent users, we can achieve a certain response time limit. Okay, so, but that I may say, I may put it in a bracket that that exclude the network latency, that is the delay from the network. Okay, so I would say that I would update it later. Okay, so now turns to we have done use cases or user story. You can use one or the two. Now, after you have done a number of things, how do you know that you have not missed important use cases? Okay, so this is, suppose we have defined 3 use cases, manage the, this is for, in fact, my very first programming job was in 1985 in the summer intern, right, a clinic, a clinic system, okay, for people to make appointment and so on, okay. And let's suppose this is the use cases that I got everything, okay. This is all the use cases I had. And then I had 3 classes, okay. I can draw a table like this so that each class has a column and each use case has a row. And if in this use case, manage patients, I do create, read, or update patients, then I would write CRU in here, okay? And also if in the make appointment functionality, I put, I can create an appointment, then I put a C there, okay? Similarly, if I have record a visits, that's different from making an appointment. So that is the patient actually come in, so I record that he's come in so that I can build the insurance company or, and so on. So I would create a bill. After you've done this, okay, first, CRUD stands for the 4 very basic operations to our data. Create, read, update, and delete, okay. After you've done it, you may figure out, appointments are only created but never read or updated. Is it a problem? You have to think. And bills are only created. Is it good enough? Do they need to be processed? Okay. And also patients are missing the delete operation. Is it okay that they're not deleted? Okay. And so this was my first crude analysis. And after that, maybe to fix things, I would have to modify an existing use case that the make appointment become manage appointment. Okay, so this, of course, I think in reality, actually, that manage appointment may actually be multiple smaller use cases to make things a little bit more manageable. In fact, it probably should be, okay? But here, I guess I tried to not to occupy a huge number of rows. So I put manage appointments. But maybe when you actually do your work, you probably should say one is to create appointment, one is to update appointment, okay? Or another one is to, or update, yeah. So probably manage now as an afterthought, instead of just make appointment, I would say change appointment. So there's a make appointment and change appointment. Better, okay, better than, because if I only have one use case like this, remember in the end, you would write event flow of the steps, the interactions, right? If you want to write that, it's going to be slightly more complex, okay, if you only have one managed appointments. So better to actually split that into two. One is make appointment, the other one is update appointment. So the make appointment will have create, and then the update appointment could have LUD. Okay, so looks like this is something I should do after class. I would try to improve these slides, okay, if I remember. Okay, hopefully I remember. And also record a visits, create bills is missing LUD. Okay, maybe I can create process payments. Okay, that process payments would read, update, and delete the bills. Okay, because maybe the delete function needs to be there because maybe I made a mistake creating a bill that that shouldn't be there. Okay, so maybe I hit the wrong button, and maybe it's another patient who come in, but I choose that particular patient, and I created a wrong bill. I need to delete. Okay, and also process payments means you actually collect the money from maybe it's paid by cash, maybe it's charged to the insurance company, but in that case, you need to read and even update it because the payment status should probably say paid. Okay, after is so now after these two changes, you know our bills class and our appointment class are complete in our set of use cases because all operations are there. Okay. So here, there's another one. Okay, manage patients. At first, I thought it's quite fine not to have delete because delete, I thought, is a very dangerous operation because if I delete a patient's record, then if the patients come back, maybe he or she needs a referral to another specialist, or he or she is very ill elsewhere. So he need to find his, let's say, allergic response to some drugs that under my care. So I need to provide the patient's record to another doctor. Okay, if I delete it, could it be a problem? Well, that's true. So that should not be allowed easily. But another problem is, what about you create a patient incorrectly? Okay, you by mistake, you're training a new clerk at the clinic, and he just created a wrong patient record, and you still want to delete it. So the delete probably still needs to be there. Okay. It just needs to be done more carefully. And what if something from another system, okay, if the database already exists, then what do we do? Well, I think it could be possible that, let's say, something need not be created because it exists, that whatever we're developing may coexist with another system that exists before us. Okay, so this is how you can use CRUD analysis, CLUD analysis, to help us uncover the incomplete set of use cases. Okay, so these use cases are incomplete. Okay, so now we want to get into OO principles. I've learned some students may not be very strong. And also, even if you have learned well, you passed your previous OO programming course, maybe it's a time for you to do a revision of what OO programming is about. Okay. First, so these 5 are the main areas in OO programming. Data encapsulation. What does it mean? It means in the old day, before we design system in the OO approach, we divide a system, okay, organize a system into subsystems based on functionality, okay? But OO suggests that function may change more frequently, but data actually are more stable. So they suggest that to use data as the main consideration to structure a system. Also, students may ask, why do we need to structure a system? Imagine, allow me to make an analogy of a human organization. If we have a very large company, okay, if there's no structure to that company you won't be able to manage it. But you can divide it into business units, and each business units perhaps further down in smaller departments. So you have business unit head and department head to provide the leadership, okay? And also this is how you report to the next level up. And in this very similar way, you also want to divide a system into smaller units. So at the top level, you can divide it into subsystems. And then under a subsystems, you can further divide it into classes. And this is what we could do to manage complexity. But the introduction of data encapsulation is based on the belief that data is more stable than functionality. So it should, if we want to have a more maintainable, easy to maintain, stable system structure, then data should be the main consideration. How about information hiding? Okay, we know each class, each object has some data attributes, but if we require people to get at those values using getter and setter method, getter method is to read it, setter method is to update it or create it. And by requiring access to data values through getter setter, we are basically defining an interface. And that means the system design is decoupled into 2 layers. One is the interface known to the outside world. One is the internal implementation. And by dividing it up into 2 layers, that means our implementation can be updated to make use of a faster algorithm, let's say. But as long as the interface is unchanged, then all the callers of that service will be unaffected. They can, they don't need to be updated with new API calls. Okay, so this is also another attempt for OO to give us more stable system. The third one is inheritance. Basically, the idea is child classes inherit from parent classes. This allows us to reuse, and it also can enforce the principle that we're given a parent classes and we don't want to directly modify it. If we really want to have a slightly different behavior, we just define child classes, okay? And then that child classes, we can override whatever with new data attributes or new method, okay? So this is also believed to help us to continue to reuse and without by reducing the main software maintenance effort. But interestingly, okay, not everyone believe inheritance is good, even though in principle, who doesn't want reuse? Reuse is a great thing. But now you already have two data encapsulation to help you structure the system. By adding inheritance, you are adding an extra okay. Sorry, I was distracted by a question, but I'll read it maybe during the break time. But you are adding one more dimension. The more dimension you are dealing with, okay, the more complex it is. So not everyone believes inheritance is beneficial, including me. So even I have, since day one, I have no problem managing OO design, okay? But I don't believe it's beneficial, okay? And in fact, my opinion, there are other people who design languages also think the same way. For example, the people who designed the Go language. So Go language support data encapsulation, okay? But it doesn't support inheritance. So there are people who think adding inheritance actually is harmful, okay? Something can be done doesn't mean is beneficial, okay? And if you want to reuse, another thing you can use is composition. That is, for example, a department has a department head and then staff. So this is relationship is called has-a, okay? Not like the inheritance. An isosceles triangle is a triangle that with two sides equal lengths is a special case of, is a specialization of a triangle, okay? Triangle is just has three sides, but no limitation on how the length is limited. So by making it more specialized, we can use inheritance. But again, we don't have to use it, okay? Some language don't support it. And of course, we know assembler doesn't support inheritance too. But it's the language that ultimately got executed. Polymorphism refer to method being called based on the class, okay? And so depending on which level in the class hierarchy. So plus, if you apply it to the numbers, is addition, adding numbers. If you apply it to strings or list, it is list concatenation or string concatenation. So it's the same operation, okay? But I mean, the operator or the method name may be the same, but depending on the class or the type of data, it can call the right thing. That is also one of the things in OO. Okay. Frequently need to be considered. The question is, when do I use a class and when do I use primitive data type? Okay. Consider that in a homework class, you want to have a due date field. Okay. And should this due date be a string like this? Okay. Year 2020, 2020 year and November 30th, or you use a date class, okay? Also, lots of time you have the date class already provided to you in a large library you can use, okay? Which ones should you use, okay? Depends, okay? If in your system, you allow students to apply for extension. Okay, student may apply for 1 week or 2 week extension or 5 days. Okay, and at the end of a month, okay, you cannot just add 5 to it. You have to take into account whether the month has 30 days, 31 days, or even less. And of course, even in February, you have to take into consideration of leap year. Okay? So how do you do that? Okay, you need a date class to handle that for you. Okay, and you want to capture it in a date class. You don't want that sort of very clumsy logic to mess up your main business logic. Like this is like date, advancing the date for 7 days, 14 days at month end. Is about month date rather than your business. Okay, so you probably want to and contain it inside a date class. Okay, so if you need that sort of operations, you would use a date class, existing one, or you write it yourself. But if you only need to compare for equality, okay, or do a simple comparison, okay. For example, if you only need, if there's no extension, okay, for the homework class, but you just need to list it in ascending order or descending order. You don't need to operate on the dates. Then just doing it the string approach would be good enough. So the answer somehow depends on the complexity of the operations you need on it. The more complex, usually you need the class. The simpler it is, especially if it is provided by the programming language that you have, then you don't need anything more, because string comparison is simple, especially if you put the year before the month, before the day of month, then a simple string calculation, string comparison would be good enough. Okay, okay, now slightly advanced principle called Liskov substitution principle. I have to admit, many years ago, I have to study it 2 or 3 times, go through it 2 or 3 times to fully understand it. But hopefully this time I have put in front of you easy to understand example. Okay, I painstakingly prepare those examples for you. I hope it helps. So Liskov is a well-known computer scientist, especially with expertise in OO. And so I'm not sure if it is a woman or man, okay? But assume it's a she, okay? She came up with this principle that ensure a proper way of doing inheritance, okay? Assume you still stay with inheritance, okay? Because after all, Java, one of the most popular programming language, support inheritance. So you need, even if you don't use it yourself, you probably need to read other people's OO code. So there's no point, no choice but for you to understand it before you can understand other people's code. And also, as a programmer, you often need to modify other people's code. Okay, so I'll let you read the original definition yourself. But in the original definition was given by Liskov. But let me use the simplified wording. Okay, it means if you use an object of a child class, okay, in place of an object of a parent class, okay, the program should still make sense. Okay, otherwise you are violating this substitution principle by Liskov. Okay, so this means the child can always be substituted for the parent. Okay, put it this way: suppose we're using geometric shape. Okay, as an example, we have a rectangle class with 2 methods: set width and set height. Okay. If you define square as a child of rectangle, okay, in that case, you are violating Liskov's substitution principle, because now the set width and set height inherited from rectangle, because we're saying we're trying to define square as a child of rectangle. We clearly, we know square and rectangle are related, so we put them as parent-child, but this is a case of putting them in the wrong direction, okay? So if we put set width, set height in the square by inheriting from the rectangle, then it doesn't make sense, so it's bad. And this is another example, okay? For example, my collection is just, you can put any number of items in the collection, okay? For example, a list. So a list is a case of collection, okay? A collection of data. And also my array, an array of data, okay? If we defined an array as a child of collection, are you okay? Or are you violating the Liskov principle? Okay, yes, you are violating Liskov principle. How do we know that? Well, suppose we have an add item in my collection. So add item is fine, right? No problem. But how about add item to an array? Okay, an array in the normal sense would be fixed size. Okay, so adding item, if we do a good job in writing our program, we would raise an exception. Okay, we will throw an exception, and if someone tried to create an array, okay, assign it to as a variable, defined as an object of the collection, then if someone call add item, we would get this exception throw. But the violation of Liskov's principle does not depend on a compilation error or runtime error, okay, to catch it, okay? Even though you don't catch it, you may still be violating the principle, okay? But we are just doing it to try to catch it. Okay, this way is our solution to the problem by defining a new class, okay? This new class would be a base for everyone else, okay? And this base class can have two child classes. One is the more flexible my collection that can accept new items, change like on the fly, runtime, that you can add and delete items. But the other one is the my array choice, is that you would have the fixed number of items when you create the array. So this way you can have a sort of a common collection base. And then maybe a better name is to say my flexible size collection. And this one is my fixed size collection. Okay, but of course, my array is a shorter name. So the other one is my flexible collection, something like that. Okay, so this way, if we can, if someone tried to make a mistake, we will catch it. So to solve these problem of violation, okay, we need to make the good decision of how to relate the parent and child, okay? And sometimes it just let's see. Okay, yes, I asked the question right here. Okay, so that means you need to make a good decision in one of the two solutions. If you think we have two classes that are related, then you would either decide uh, which one should be the parent, which one should be the child. If you did it wrong, you would violate LSP. And also another approach is to introduce a new class as a parent, as we did with the my collection base, okay, as the parent for my collection, which is a flexible size collection, and my array, which is a fixed size collection, okay. So when we take a short break here, 5 minutes, you can also ask me question and also uh, think about how the rectangle and square should be solved. Okay, so also timer for 4 minutes.
Sure. 4 minutes. Starting now.
Okay, and don't forget to walk around, and so you have a fresh mind when we come back in 3 minutes. Hi. Okay, so let's move on to effective OO design. Okay, let's look first at a measurement. Okay, it's called depth of inheritance tree. It measures the maximum number of levels from the root nodes to the leaf nodes. So the leaf is at the bottom, the root. Remember in computer science, we always draw a tree sort of uh, inverted. So we say the root is the top, okay, and the leaves is in the bottom. The more levels you get means more complex, okay, and also so it takes hard is getting harder to understand the class the class structure, okay, but this is clearly not the only one measure there is to measure the complexity of a system. For example, well, how about I forgot, it's the spanning of the tree. For example, if each parent have 10 children versus a parent having average of 2 children, which one is more complex? Of course, is the one with 10 children would be more complex. So there are additional measurements. So I'm just showing you one of the common measurements. So there are a number of measurements to measure software complexity. Okay, there's a link here. You can probably find additional link. There is a class of software tools that it can perform a static analysis. Static meaning that it try to analyze some code without actually running it. So you can almost think of the tool as a special class of compiler. But unlike compiler generally want to generate the executable code from your program, this one try to derive some measurement like DIT to measure the complexity or to try to figure out if there's any bad coding practices that the code is doing. So this is a special class of software tools that, let's say, if one day you are in charge of software quality for a team or for a company, then maybe you can look in this area. Okay, so but we definitely this area can be become a course by itself, or even can be a PhD research. So we don't have time to go into that, but just let you know there is this family of tool. I forget. I don't even have put the name here. It's called static analysis tool. Okay, static analysis, static code analysis tool. Okay. So now, our main thing is we want to have good software design. So but first, the word software design, we can refer as the activity of defining the software architecture, components and API and those things. But it can also be referred to the work product of that activity. So in this case, when we say comparing software design, we're comparing the work product. Okay, we are not talking about the activity of designing software yet. Okay, that would be the follow-on course, COM S351F next term. There are two measurements that would or two basic ideas that we would measure software design quality. One is called coupling. The other one is cohesion. Okay, coupling. Let's see. I probably design criterion 1. Okay, criterion is the singular word for criteria. And coupling refers to the dependencies between two subsystems. Okay, that means if two subsystems are interrelated in many ways, many different associations crossing the subsystem boundaries. Okay, we'll have a diagram shortly. But if we have many associations between two subsystem boundaries, we call it a tightly coupled design, and which is not very good. Okay, because if two subsystems are so tightly coupled, that means any change on one system, it will not only affect inside that subsystem, it also affect other subsystems with all those associations that crossing the system's boundary. So tightly is bad with many associations, while loosely is the better designed with few association. But why do we think it's bad to have many? Well, because of the high level of interdependencies. That means if you modified one class, one place, okay, then there's a good risk that you break something. Of course, if you try to stick to changing of implementation, okay, you don't change the interface of the objects, things will be better, okay, but still, the more tightly coupled, the worse, okay, less. We have some diagram right here, okay. This design two, okay, we're trying to design question subsystem. This is like a test subsystem, a quiz subsystem. I mean, a testing system. There's an answer system, okay. So a teacher class has multiple quiz, and each quiz has a non-empty set of questions. And so quiz and questions, and here each student will have his own answer set, okay. And yes, please turn off your mic. One of the students turned on the mic accidentally. I didn't know I have enabled your mic, but please, okay. Yes. Now, so a student may be making multiple attempts to take the quiz. Maybe it's allowed for them to practice. So this has 0 and ... star to means multiple. Okay. Initially, it's 0 before the student take it, and then the set of questions will consist of a number of individual answers. Okay. So in this second designs, we have 3 associations crossing the boundaries of the question subsystem and answer subsystem. But if we put the student in the right place, okay, in this answer subsystem, that reduces the association crossing the boundary from 3 to 2. So in that sense, design 2 is a more tightly coupled design than design 1. Okay. And so remember, coupling, this is, you can think of it as a simplified view of understanding coupling, which try to measure the number of association crossing the boundary. But of course, maybe you may have additional subsystems too. So it's not in a complete system. It's not just between two subsystems, but it between all is subsystems. Okay. But this is not necessary. Okay. Let's see. Let's go to the other concept called cohesion. Okay. Cohesion measure the degree of relatedness of classes inside a subsystem. Okay. And which means if I have more classes related inside it. For example, in here, we have the count of 2 for question subsystem and also the count of 2 in answer subsystem. And here, well, we have a count of 2 for the question subsystem and count of 1 in the answer subsystem. So the count is reduced for the answer subsystem, okay, as far as the cohesion is concerned. But cohesion try to measure the association inside the subsystem, and in general, the more associations, okay, given the same number of classes is good. Okay, so this cannot, I guess, I can make it slightly, this discussion, I didn't say it in the slide, but we can make it a little bit more complicated, is we don't just count the association inside the subsystem, but perhaps it should also be adjusted by the number of classes. So let's say here we have a measurement of 2/4, and this one is measurement of one relation over 2. Okay, so it's for the 2 subsystem is 2/4 plus 1/2, which is a 1. Okay, but here we have 2 association over 3 plus 2/3. So it is 1.5. So 1.5 is bigger than 2. I mean, sorry, this is 1 because it's half and half, right? So I didn't put down this calculation, but I may adjust this slide. Okay, but the thing is, design 1 has higher cohesion, okay, than design 2, okay, because of the relatively higher number of association inside the subsystem. Okay, and this is it's not hard to see that for both measurement, coupling and cohesion, design 1 is better than design 2. Okay, because design 1 is both loosely coupled, which is the desirable one, loosely coupled, and also have high cohesion, which is also the desirable. So we can see that it is often more like the 2 go hand in hand. Usually they go together. Usually high cohesive system is also a loosely coupled or low coupling system. Okay, so this is good design. Okay, so that means by choosing more related classes together, and in other words, keeping their association inside the subsystem is better, okay, than allowing them to be in different places, in different subsystem. Okay, easier to maintain. Okay, so that the time is almost perfect. I finished it 10 minutes before. I can stay here for a couple minutes. If I'm not kicked out of this room, we have a sort of a new instruction that we should clear the room 10 minutes before the end of class, so other next class can use it, and also you can get ready for the next class. So how about the lab exercise this week? Well, the lab exercise this week would require you to do CRUD analysis to detect that whether you have a complete set of use cases. Okay, student asked if I can talk about the 1 and 0 star. Let's see, I remember having seen it. Okay, this means a teacher can have 0 or more quizzes, or associate with 0 or more quizzes. But a quiz is associated with exactly 1 teacher. That's what this means. And in this case, that allows a teacher to be initially have no quiz, maybe when he first start out the new job. But this may allow this quiz require each quiz to have at least 1 question. Okay, so this is what it means. Actually, if you want, you can also go back to some previous class when I talked about class diagrams. Okay, this is why it's important to study for the previous class before you go on to the next class, because you absorb more, because we have more detailed discussion of that in the class diagram class. So feel free to go back it if you, but of course, since you heard it the first time, it's easy to forgot. Okay, so it's totally understandable. I guess that's why I asked you to review it once, because by reviewing once, seeing it the second time is a lot more certain that you will remember it. Remember my lesson about learning to skate? If I practice once a year, every year I'm back to the starting point and I never learn to skate. But if I practice it the next day, on the 3rd day, I can skate and I can go around the ice rink. So make sure you study it at the same timing. Don't wait until, because we don't have an exam, but if we have an exam, students tend to wait a few months at the end. So whatever taught in the first few class, when they study for the exam, is as if it is something new. So by studying, by reviewing at the right interval, you probably retain better. Okay. So, but thank you very much for the question. And so I'll give you more information on how to do the CRUD analysis to add to your list of use case description. But remember, I don't require you to define use case description for all use cases. Okay, so you only need to do a few, but probably that will not be the exercise for this week. So I would see you all Monday. Okay, so I hope you would enjoy our lab. Okay, so thank you. I'll see you. Bye bye.